Alright, time for another draftphysics.com, debatephysics.com also, and such. Video presentation. Right. So I think we'll just review some of the other videos I did that are on the website. And overview on some of that stuff. And I do plan on making another kinetic energy video where I'll go through the history again and just point out how it's pretty decisive that this is not a viable theory. 1/2 mv squared is just not good physics, not good science, not good logic, not well evidenced. It would lose at trial. So if we put it on trial, it will lose because it fails in fundamental ways as a theory, in very fundamental ways. So free energy and such. And so free energy was the subject of yesterday's video, and there's so many people arguing so many different little angles. You take the Faraday paradox. That's supposed to be a D. Hilster video this weekend. And the simple solution to the Faraday paradox is just simple stuff like, your probe wires are in the experiment. You can't measure the voltage because there's no way to put your wires into the experiment without them becoming part of the experiment and detecting something that none of the other circuits are actually doing. So your test instrument will fail. And this gets to the measurement problem in quantum mechanics and lots of other things where, there's no logic, for you to, do what they say they're doing, because you can't do it without changing the environment that you're testing, and you can't test it if you've changed it. That kind of so this should be pretty decisive and say, okay, we have to say it at least differently. You can't say it the way they're saying things when they know the evidence is something else. And this goes to even the wave-particle duality crap, and you can't have dualities. Things aren't whatever you want them to be. They have to be they have to fit actual physical circumstances that are pretty consistent and whatever. But the conversation is so broken. People are just so all over the place. As part of that contest where as participants were obligated to watch some of these crappy videos, it's just this wooey crap like the planet is alive, it's a living organism, blah, 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 blah. It's just horrible. Anyway, it's not science, it's just mush. And why people gravitate to mush, I do not understand. So as part of this video, I did a little bit of explaining, not perfectly, but the energy. There's just really two things in the universe. There's force, the little bits of force that have momentum, and yes, they can move at frequency, they can do different things, but they're the thing that are moving, and the matter only moves when it's pushed by force. And that seems it seems that should win at trial, because yes, that's how the universe really does work. There's stuff moving the speed of light, and then there's stuff moving a lot slower than the speed of light, and and it's just dividing the speed of the force by how much force is pushing how much matter, and big things move slow and little things move fast, and it all makes sense. And it's kind of irritating that it doesn't make sense to any of you, because it sure makes sense to me. So anyway, I explain a little bit of that, and then we get on to the video that's you're just saying, why would people talk this kind of shit? So he makes up this whole story. Apparently he might have read bits of it in some sort of perspective. Apparently he gets, the people who sell stocks and gold and oil and all kinds of crap, they sell it because they make money. And so they lie and they tell a bunch of stories to try to get people to buy into some kind of gimmick. And so apparently they said something about Tesla having some technology, And he turned that into this whole bizarre story about, you know, the free energy, cosmic background radiation device that's, you know, going to save mankind from its energy woes. With his last days on Earth. Yeah, and so I'm pondering, why would somebody spend, you know, he's an older guy, you know, this is, you know, he's only got so much time left, and this is how he's spending it, telling bizarrely, insanely, can't possibly be true stories. But he's a religious nut, so, you know, they're storytellers, the religious nuts. Strong, the actual force is. It's an incredibly strong force. Right, so, you know, I'm making a simple argument that we're under a lot of pressure and we get to see some of that, right? So I put a little bit of matter in the universe. It's under tremendous pressure from the universe, but it can't feel any of it because it's equal from all sides. And so it doesn't feel any of the pressure. And the same thing's happening to us. Here we are sitting on the earth, and there's this pressure pushing us down, and there's not the same amount of pressure pushing us up, and so we move in the pressure. And it seems like it's a pretty strong pressure. I mean, you know, 9.8 meters per second, so kind of a lot of movement. And that on other surfaces of other planets, the pressure can be much higher, you know, 100 meters per second. I don't know what I don't know what it is on Saturn. Maybe there's some planet that's actually dense enough and big enough, you know, where you get a big number. I mean, the sun is only 80. You'd think it would be more than that, but it's only 80 meters per second. So, you know, just because it's really big, but it's not dense. You know, it's not big atoms. It's little atoms, far away atoms. Not a lot of atom density. So anyway, but yeah, it's you know, 10 times more gravity would be pretty significant. So you can just sort of understand that, you know, this is a pretty, you're getting some taste of just a little bit of how powerful the amount of pressure is, because there's some of it's been relieved on one side, your ass, and you're being pushed pretty hard into that deficit. So yeah, there's a lot of energy in the universe. But the catch is you need a planet to create a differential. You need a ton of mass to be able to shield yourself against the pressure on one side. So there's no magic element like lead or something. There's not some special element you can make a shield out of that blocks all of the gravity waves. You know, the gravity energy, the pressure of the universe. So you can't make some kind of shield that gives you the capacity to absorb a huge differential in the pressure. You have to create it with a lot of mass. So you're not going to create a free energy device or an anti-gravity device without making a device as big as the Earth. And what was propelling this Tesla car? So he doesn't tell us. So yeah, so this story is just crazy. First he has the car going, you know, oh, it goes 400 miles an hour in 6 seconds, and there's no batteries and no, you know, nothing. And then he takes away the motor, and he takes away the wheels, and he says, yeah, it still goes 400 miles an hour, blah, blah, blah. No propulsion system that we're told about. Somehow, I guess he's using some EMF, you know, some maglev kind of propulsion system that's part of this 1-foot panel that does all of this magical stuff. And it's just such a silly fucking story. And you're just saying, why would, you know, if you're part of an organization or a group of people that are doing science, this is a huge blow to your credibility if you're going to let people talk this kind of garbage. So it's just, it's a video for entertainment purposes, I suppose. I mean, this should be done. I mean, there should be people who actually talk about what people are allowed to say and still be credible. And this is worse than flat earth theology. This is really way out there. These are just lies, frankly. This isn't reasonable storytelling. Really sell it because nobody can use it. And none of us. Yeah, it's so illogical. You know, this whole conspiracy, all these people conspiring to keep things from you. All these people who have kids and a grandmother, and you know, a family that wants to be proud of them, and they're all doing this, conspiring to fuck us all over. This is too silly. Alright, so that was yesterday's video. And the day before that, I went through a list of, you know, I do try to write stuff now and then, and, you know, I don't find it very comfortable because you have to be so careful in how you word everything when you're writing something. You're so, at least I am, I'm so much more conscious of saying it exactly right and blah, blah, blah. And it's just tedious and obnoxious and irritating. I did see that in another one of the math and science guy, so I did a couple of his videos will come up later. You know, he kept saying spontaneous in one of his videos over and over and over. It's spontaneous, and then it spontaneously does this, and you're just saying a physicist really shouldn't use that word, you know. I mean, I use it sometimes. I use the word random. I use words that I just know, wait a minute, you're not supposed to say that word because it's really not the truth. And, you know, even physics hasn't done that. It hasn't cleaned up its act enough to know it can't say some words because, yeah, they're really just not scientific. Can't happen that way. So anyway, this is going through the list of theory and the history of mankind and all this crap. But the simple experiments, again, if you really do them, it doesn't work. Yeah, so I think I'm just talking about how kinetic energy just doesn't work. A lot of what they promise us as, you know, the quantum mechanics, they say it's the most precise and accurate, you know, theory in the history of mankind because it's measuring the weight of an electron. It's just predicting one single experiment based on a formulation. And yeah, so anything could do that. I mean, there's 4 million different ways you could get to that and say my theory is the most predictive and accurate in the history of mankind because it predicts one thing over and over again, gets a better and better and better number each time it does the experiment, finds better and better ways to do the experiment. But it's always just measuring the same thing, and it's just kind of silly. And the silliest part is that it's very circular. It's just saying, oh, you know, there's a rule, a conservation of energy, and it's basically saying, look, I conserved the energy and I measured the energy out and it was the same as the energy I put in, and therefore my theory's right. Well, no, that's just the conservation of energy. It doesn't have anything to do with your stupid theory. You know, you could make up any number for the energy in and just say, yeah, I got a number out. Well, getting the same number is not a grand accomplishment. You're supposed to do that. So it's just kind of bogus that because they're measuring it finer, it's like saying because they measure the speed of light to 700 digits, that somehow their theory is correct. No. You're only measuring the speed of light in one way. You know, it's one experiment. That we can't do this, that we can't try the experimental evidence, that we can't put this. So yeah, the whole idea is to have the trial. You know, I can't read what I wrote. I guess I should have put it up here so I could, yeah, you know, but it's you know, an accurate statements regarding conditions and circumstances. I mean, that's what we're after, is accuracy. We're after a true description of the actual function of the actual universe. And I would argue that yes, the pieces of evidence is there's an indication it's mechanical. There's an indication that's, you know, made of small stuff and bigger stuff. The small universe is the first universe. That's the universe everything's really interacting in. The electrons and protons are making my words. I don't make them. You know, this physical body doesn't make them. Electrons and protons make them, in the sense that they have to do it first. They have to be in the right arrangement, and they have to do their electricity thing, and they have to do the things that they do, you know, for anything else to happen. It all falls out of the small universe. It doesn't, big things don't do anything. You know, lots of little statements like that if put on trial can win the day and be axioms. And those axioms are so much better than the silly nonsense axioms of conventional physics. Going to sneeze. Alright, should be back. Play a little bit of this. Out the logical path. So as you start putting a couple of different experimental results together, they point in the next. Yeah, so that's just logic. Logic is you learn things, okay? You jump in the water and this wetness thing happens to you where the water sticks to you and it, and you learn something and you put together these facts and then you step on an electric wire and you get electrocuted. And so the water is creating conductivity and so you add it all up. But the facts really point to the next fact. You draw conclusions and speculate about what's going to be true based on these pieces of information, and the pieces point to where the next piece goes. Okay, that you don't have to have interactions. That's something that just happened without. So I'm arguing about the word spontaneous, probably, that there can be an action without a cause, and this really doesn't happen. Nothing happens spontaneously. Everything is a byproduct of the history of where everything's going and where it will be, and it's cause and effect, and there's no just effect without a cause. It doesn't happen, isn't scientific, there's no evidence for it. Alright, so we'll move on to the next video, which was the response video to the dialectic guy about the sky falling up. So this is the same argument that the PBS space-time idiot has made, and the Science Asylum guy has made, and I don't know, yeah, Veritasium, he's probably done it too. Where they pretend that gravity's not a force and that it's, it's just like as if the world is expanding at this incredible rate and blah 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 blah, and it just doesn't make any sense. And they go to all this trouble to animate it and go to all this bullshit, and the fact is you can counter the argument. There are flaws in what they're saying. It isn't the magic trick they're making it out to be. It's not the illusion or the spatial illusion that's fooling our eye, or you can find the exact point where they say something that nope, it just doesn't work that way. Because if the ground was accelerating, the fact is it would go faster and faster and faster, and it would be going it would be doing it constantly. There's no counter, there's no ground stopping you from moving. So when you free fall, there's a limit, there's a point where you hit the ground. So the building, if you're falling down off a building, the building never goes 10 million miles an hour because you never go faster. And we know you stop going faster at 100 miles an hour. So the building stops moving out at 100 miles an hour. Why would it do that? It doesn't have any problem with the atmosphere and all this other crap slowing it down. So clearly we don't fall at the constant rate because we are in an atmosphere, and the atmosphere sort of proves that now it's not the building that's moving, I'm the one moving, because it's my terminal velocity that decides when I stop moving, because I am actually hitting air molecules and they're actually moving. So if we make the air move too, okay, then you're still stuck with the problem is if the air is constantly accelerating, it would already be at 1 billion miles an hour. It wouldn't have any problem. Why would the air start moving only when I jump off the building? It's already moving. It's already accelerating. While I'm standing on the building's supposed to be accelerating. If it's accelerating, it's gaining velocity. So when I jump off, it should be going really fast by now. It shouldn't just start to go because I jumped off of it. Why would the building say I can't move and while I'm standing on it, and all of a sudden the building starts moving when I jump off of it? Little things like that just proves it's crap. It's a crappy little word game. It's playing little games with the relationships that exist between things, and it's just crap. Alright, so I was just sort of explaining first what I think gravity is and how it works, and how it's just an absorption of momentum. You can't move something big without pushing it. You have to have 10 people to roll the giant snowball or something. So you have to consume energy to move matter. And that's a real consumption. So all the matter moving inside of the earth is consuming energy to maintain its motion. And that consumption is the gravity differential. because the target's irrelevant to the progress of the light. The light couldn't care less about the movement. So I was just pointing out how the light clock, if we could actually build one, would in fact prove the case. It would prove that you know, you can tell whether you're moving or not. You can do a physical experiment inside your spaceship that will tell you whether you're moving or the universe is moving, because light doesn't care about any of this crap. It's moving through free space, empty space. It's not affected by your frame or anyone else's frame. And it will tell you, you will see exactly that light does exactly what it does, independent of any frame. So, you know, it's just how you word the statement, you know, Einstein versus. Because Einstein says something similar, but it's distinctly different, in the sense that he's saying that light is affected by your frame, as much as he's pretending to say the opposite. He's not saying the opposite. He's saying the frame, the light will somehow compensate and behave as if. Okay, and it won't. Yeah. So it's all gimmicks. To have a difference, there has to be a difference in what forces are acting on two objects. That's what gives something momentum, is having motion. Alright, and the motion is in the field, so it's about what forces are acting on you. You have to have a difference in the forces for you to do something, for you to move. It's just a difference in pressure. And that's all there is, and there isn't anything else. So that's basically arguing, how can the Earth be moving and the buildings? You know, obviously the Earth and the buildings are connected, so, you know, they all have to be accelerating. So how could the Earth be getting bigger at 1,000,000 billion miles an hour? So I'm just making the point that we only do free falling for little tiny measures of time. If the Earth was if the Earth was creating the illusion of motion by it moving, the fact is, it's not moving at a constant velocity, it's accelerating. And accelerating means it has to go faster and faster and faster. And because it would be free falling all the time, that is, accelerating all the time, it would reach preposterous, ludicrous speed in no time at all.
And understanding opens the door to what's called the river model.
So all of this animation, all of this trouble, you know, just to talk crap, you know, word gamey bullshit. And then he ends up saying the river model, when it's not really a river model, but, you know, it's a fluid model. And that just ends up being mock gravity. And so that's the irony of it. They're using mock gravity, which is Lesage gravity, to explain gravity. Alright, but they're saying it's not, you know, they're saying that analogy isn't true, that it's really space that's the river. So they're making the river out of something that doesn't have any substance. And, you know, that's just such a, it's just cheating. We know that you can't, you know, it's worse than dark matter. It's like saying dark space. Why did they just forget about having matter? If you can bend space, then why don't you just make consolidations, you know, clumps of space, and create your dark matter that way? I mean, why don't you just make dark matter out of space, empty space, and therefore it won't have to have any other properties except gravity. I mean, it's just such a cheat. And I just don't know why people find this appealing. A river of empty space? I mean, it's too silly. Oh, and then I did a little bit of the D. Hilster thing at the end of the video, just because it was live at the moment I was making the video, but it's not really a significant point being made. Alright, so the other video was the math and science guy. So the interesting thing, I leave commercials on just because I want to see what's getting advertised. And this guy actually has a commercial for his science videos. And it's, you know, a kind of highly produced commercial. I mean, it's not like just him going, buy my series of crap. You know, it has the voiceover and all of the nice graphics and all that kind of horse shit. So it is kind of funny that it's a YouTube commercial. And I did notice that he has over 1 million subscribers. And yet his videos only get a few thousand views. And you're just like, wow, what is with that? That his subscription base is so specific in whatever they're interested in that they don't even watch or click on the videos. So that's sort of surprising. When you have 1 million subscribers and you're getting a few thousand hits, I mean, that's not too good. It's not a very good audience. It's not the audience I would want. So anyway, I tried to find the bits where he talks a little bit about kinetic energy, but it's just such a tiny bit. And like I said, the guy's at NASA, an ex-NASA engineer guy, so he should really know this. He should really know, kind of in his soul, that there's a real problem with this kinetic energy formula. That spaceships really don't work that way. It's just about mass and velocity, and there is no, because something's little and going fast, that somehow it has so much more capacity to do work than something slow and big. Because it's not how spaceships work. It's not how things move in space. Things move in space purely because of momentum. And there is no sign of the kinetic energy formula to be found anywhere in the motion of objects in empty space.
The third important thing here that we can then tie everything together, and we call it the kinetic energy.
Right, and so he doesn't really go into kinetic energy, he just plays the game of talking about the difference between active energy, living force, and dead energy, stored energy. So he just does the potential and active energy argument instead of the kinetic energy versus momentum argument. So he doesn't go anywhere near making a distinction between what is momentum and what is kinetic energy. Trying to pretend to say they're both real things when no, what they're both doing is saying the same thing is not the same thing. That an elephant, one of them says an elephant is a duck, and one of them says an elephant is an elephant.
Kilograms, the same units as before. And when you take a map...
So then we have the squared unit, which is really, he's saying, and he overtly says it, it's meters per second, which doesn't mean you square the velocity. When you're saying something happens every second, you're not saying it happens the squared number of seconds. It could happen 2 seconds, it could happen 10 seconds, it could happen 2,000 seconds. Why would you try to symbolize it or represent it with the square? The square doesn't represent it. Squaring a number isn't the same as counting how many times the number happened and then multiplying. 4 times 20 is a lot different than 20 times 20. 4 times 200 is a lot different than 4 times 20, 4 times 4, or 20 times 20. I mean, it's just very different. Can you get back and up? Yeah, he always resorts to this roller coaster argument, which really doesn't have anything, this is just energy conservation, switching between active energy and storing energy, and your storage is in gravity, and there's just nothing magical about it, right? The higher you go, the longer you will free fall. So if there's a point you're going to say that's my end point, it's just about free falling, and the fact that if you are free falling and then I put you back up higher, you can free fall again. It's just about how much time you're going to spend falling in the gravity, and that's the time you're collecting the energy. You can't collect it when you hit another object. If you hit another object, then your energy goes into the other object. So you only collect energy while you're free falling, is the simple argument. And it's all just about time. Work is time times the force. How long is the force applied? It will tell you how much energy you're going to get from the force. This is.
You can see how energy...
I can't really hear this part, so we'll go to some other part because I can't hear it. Much time it repeated. So it's nonsense. It's completely bad. Alright, so again I'm talking about the fact that they're saying, they're using the notation of the squared symbol to represent the statement 9.5 meters per second per second. So it happens over and over and over again, but it can be any number of seconds that the event is taking place. So when you're in gravity, the first second, 9.8, the second 9.8, the third second, 9.8. You wouldn't go 9.8 squared, because you would do 9.8 times 3 seconds, not 9 seconds. 9.8 seconds. So it doesn't make any sense to use the squared symbol because you're not really squaring the number. It's a bad way to notate, okay, to put into a simple notation a concept. It doesn't represent the concept accurately. You're not squaring. Doing something more than once is not squaring. Or a concrete movement you would measure its capacity to do that in the same amount of stuff, the same amount of these things. So a joule makes sense, but so did a foot. So having a unit makes perfectly good sense, a way of measuring energy, but clearly the units don't add up. When you compare momentum to kinetic energy, you get completely different unit answers, because both can be converted into newtons. You can convert a newton into a joule, and you can convert a joule into a newton. So they're both basically just a definition of an amount of weight or pressure, and there's no way of denying that. So the unit already proves that you can't have these two formulas with two different answers. The fact that momentum is in foot-pounds doesn't change the fact that I can convert that into joules. And I have two formulas giving me two different answers. It just doesn't work. Alright, so I think we're down to here. So this is another one of his videos. And called Newton's second law, part 1. Yeah, so it doesn't really get to the kinetic energy part, but it does get to just the physical interaction parts of energy. Now, Richard Feynman gave a good example of this, like, you know, a mother. Yeah, right, the conservation of energy, and that, you know, like I said, Feynman's analogy or storytelling, and but he didn't say the key words that, you know, what if we could make the blocks smaller or we could make the blocks bigger? So the idea is that energy is in clumps in the universe. But what the kinetic energy formula basically says is that somehow if I break the clumps into smaller pieces, they'll have more energy. That the total amount of energy be higher, because now I can give them higher velocities. And the higher velocities end up being the squared term, will end up adding up to more velocity because I'm squaring the velocity. So I can, you know, the lighter I make the universe and the faster I make it go, somehow I give it more energy. When I think it's pretty clear that mass is really important in terms of what hits you. When something hits you, it's not just about how fast it's going, it's about how big it is. So if a feather hits you at 50 miles an hour, it's going to be a lot different than if, you know, a brick hits you at 50 miles an hour. To something else, they're saying that's a counterforce. Well, it's not really a counterforce, you're just giving away your motion to something else. Right, so, you know, this is where he talks about friction as if it's a force. Friction is just your force leaking. So is heat. Heat is just the byproduct of, you know, energy. It's your momentum. It's momentum. Heat is momentum. It's just smaller bits moving. And they can't move unless they get the energy from something. So that's part of the friction creates heat. So you have two elements to friction. You have the actual fact that something big might move, big pieces that you wouldn't call heat. Okay, like you can break glass into little tiny fragments and bigger fragments. Well, the bigger fragments won't have any heat, so to speak, as you measure it, and you're only going to count the little tiny fragments that have energy. But the fact is, it's all the same thing. It's just momentum. It's just masses moving. And frankly, you know, a big giant boat going across the water could be called heat. It's mass moving. And that's all the atoms are doing, and it's all just momentum. It's all just a clump of motion. And it's really what's moving are electrons and protons, and you're just saying how much atomic weight, how much atomic particles are moving, what distance, period. That's the substance of energy. That's all the energy. All the energy is just one thing. It's just atomic particles moving as we see it. Obviously we can't see force moving, so it can't be relevant. But that's all there is. The force has momentum. Like, again, it's a pressurized universe. Pressure. That's what it is. Pressure. That's what it is. It's just pressure. So he has the F equals ma, the famous perversion that they call Newton's formula. It's not Newton's second law. So he's saying this is Newton's second law when it's not even Newton's physics at all. It's Leibniz's physics, and it's just very unfair to Newton. Applying a force per second is an undisclosed amount of pressure. Right. So per second isn't it can be almost any kind of number. It can't be the number squared. It's not the velocity squared. A velocity that's being changed by a constant force is not the velocity squared. Convoluted, just nonsensical on its face. So you're right here, you can see that he's doing it right here where he says meters per second squared, and it should be meters per second. A velocity, an acceleration isn't meters per second squared. If I'm accelerating a car, I don't say meters, it's going 25 meters per second squared. I say it's going 25 meters per second. And if I'm going to increase the velocity, I say it's going to increase at a rate of 25 meters per second. Not per second squared, per second. That's the rate it's going to increase. And it might increase for 10 seconds. It might only increase for 5 seconds. I have no reason to square this term. So it's like saying something's going 50 miles an hour squared. Why would I say 50 miles an hour squared? Why would a speedometer say you're going 50 miles an hour squared? You're not going 50 miles an hour squared. You're just going 50 miles an hour. And maybe you can do it for 10 hours. Maybe you can do it for 500 hours. But I won't add up the total before I get to it. I can't put the squared term there and say that's the answer, because it's not the answer. So it's clear just how broken this physics is that they would even, like I said, this is like saying 50 miles an hour squared. No one would say that. Like Jupiter or the Sun, and use the huge advantage of being in space, the 400 times better. Oh, okay, so I was talking about the Eddington experiment, of course, and such. So we'll do this last one and call it a video. Alright, so this was a comments video, and it ended up just being on two subjects really, the Eddington experiment and 1/2 mv squared. And it was, you know, like all my videos, it's good arguments. So this guy had posted a comment about the fact that yes, he concurs that in his research he can't find any real good evidence that this experiment has ever really been done competently, ever. You know, it really hasn't been done well, period. And he doesn't make the 400 times better resolution from space argument, but I mean that to me is the big one. You have a huge advantage doing this from space. You don't need an eclipse. You can do it anytime you want. And you have 400 times better ability to see what you're measuring. 400 times better ability to see the measurement. I mean, there's just no logical reason this isn't done from space. Stuff and where there's no stuff. Okay, it diminishes very quickly, and you know, because it's atoms or no atoms. Right. So I'm talking a little bit about, you know, it gets a little complicated when people say, well, yes, but we have other experiments where we've seen light bend around suns. Well, yeah, because there's a whole bunch of crap around the suns. There's a whole bunch of particles flying out of the sun. The suns have huge atmospheres. Yeah, they're not blue like ours. They don't show up as much, but they're there. You can see them with the right camera. It's a huge, giant atmosphere. of particles, and so all you're getting is scatter. And some of the scatter takes the shortest path to you, and some of the scatter takes the longest path, and that's all. So yes, it will appear as if the light was bent, but it was bent in all directions, not just your direction. And it wasn't bent by gravity, it was bent because it hit an electron and moved it in a new direction. And the photon has now been changed in its direction by interacting with electrons. Simple answer. It's almost like I could talk about the redshift argument for the galactic, space expansion argument, that the redshift could simply be explained by the fact that, yes, photons traveling through empty space do now and then encounter a hydrogen atom, and in that process they are slightly degraded in their frequency by the interaction with the scattering electron. Compton scattering. It's a real effect that it degrades the frequency a tiny, tiny bit. So obviously over billions of light years of travel, that little bit would become rather significant. Okay, you are standing this way. Alright, so I'm making the lever argument and the pressurized vessel argument, and they're decisive arguments why kinetic energy cannot possibly be the truth. It isn't a description of reality. And if if people would just build these devices, they would see that the kinetic energy theory predicts free energy, and it doesn't happen because it's not accurate. It's not telling you the truth. It's not describing the conditions and the circumstances accurately. It's an inaccurate definition of energy, not an accurate definition of energy. Let's just believe velocity is squared, because gravity says there's a 4-to-1 relationship. So, and that 4-to-1 relationship, the fact that you have to go 4 times higher to go twice the speed. So you have to go 4 times higher to go twice the speed. But you're only going to fall for twice as much time. So falling this distance, 4 times the height will only take twice as long. It won't take 4 times as long. And when you hit, you'll be going twice as fast, not 4 times as fast. Clearly, it's just an illusion to be fooled to think that 4-time differential is anything other than really a 2-time differential in all the important ways. It's twice the time you're in the force. It's twice the time free falling. And all you get out of it is twice the velocity, clearly indicating the 4 doesn't mean anything. Alright, so that's enough of a video, I guess, and such. So, just see if the one before that was a really interesting junk comment. So yeah, that was probably less useful. But anyway, so those are the videos that on the website, and I think they're good videos. Yeah. That's what I'll say. Yes, I think they're good videos. I think I'll do another one of these math and science videos. The guy talks pretty straight, but he's showing conventional theory, and it can just be shown to just be full of holes. These assumptions they've made about waves and all of that. They're just assumptions. They're just conclusions they jumped to. They weren't dragged to the conclusion by a huge amount of evidence. They wanted the conclusion. They bent over and forced the answer. It wasn't like, they didn't wait for the facts to say this is the next piece. They projected they took anything that looked a little bit like it and just, drew the conclusion. It's just like people looking at, images of bears and try to call them Sasquatch or something. They want there to be a Sasquatch. So they just find a picture where it looks Sasquatchy. Just like people who want to find magic on Mars, and they go look for a mountain that looks like a face, and then they can say, look, it's Easter Island on Mars. There's people there. They want to believe. Alright, so enough of a video. Point out that you can't access the debate physics website from here and the other version of the regular website. And you can, you can post a comment, but nobody does any of that reasonably. And you can see the comments that I haven't reviewed by just saying, just load the comment box, and it will load over here on the side. Can you see that? Not quite. See, it loaded right over there. So you can read whatever the most recent pile of crap is. So some guy did link to Huygens optics. Yeah, I've done response videos to his videos. He's a wave nut, okay? And all of his experimental videos are nice. They're good videos. But there's lots of details to them, especially building compound lenses and all this kind of stuff. So there's lots of points where you could say, well, that isn't quite right, and that's not quite right, versus wave versus particle arguments. So I'd say they're videos people should watch. I'm not opposed to that. I just don't think they're very insightful in terms of getting to the elemental functions of proving wave or particle, because he really doesn't do experiments that'll get to that point. That are good for arguing that point. Gary the Kitten Killer. So, I mean, I obviously have some appreciation for felines as a organism on this planet, and it's a it's a little silly to call me that, but whatever. Go ahead, be silly. That's all you can do. So this is the best argument they have. This is their best physics argument. They're defeating my physics with this comment. Thinks he solved physics. I didn't solve it. I proved that you're a religion, that you're silly religious kooks, okay, and that you can't grow up. You can't do anything as a sophisticated intelligence, and you can't even admit simple things that are just obvious. It's obvious the kinetic energy theory was invented by a religious kook. It never had any good physics behind it. It never had any good experimental data behind it. And you all jump to it. Why? Why? Ha 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 ha. Why? Why were you such buffoons and idiots? And so I'm proving you to be an idiot, defending idiocracy. So keep commenting, because you're just proving my point. You can't make a counter argument to anything I'm saying. You can't reclamate Huygens. Or the other guy, Liberace, Leibniz. Okay, so go ahead and try. Go ahead and show us, the evidence. Go ahead. Explain how, yes, the Mythbusters didn't know what they were doing and weren't measuring real energy and all of that kind of crap. You haven't countered any of my arguments. So, ha-ha on you, failure. Alright, anyway. Yeah, that's all you get is crap. That's all people can, that's all they have. I mean, that's, all of these videos, 10 years of doing this, and this is the best the opposition can do. This is the best argument they can construct defending how levers work. Yeah, it's just pathetic. Alright. So, till the next time and such and so forth and whatnot. This has been, like the 3,674th, draft physics video. Draft science on YouTube. And debate physics. But again, nobody wants to do the mock trial thing. That's, I could say, mock trial physics or something, because that's what we really have to do. All of this stuff should be put on trial. People make assertions, and it should be argued about why it's viable or unviable. And none of that's taking place in any kind of rigorous, fair, disciplined manner. It's just pathetic.